So I've been sitting back there. It's been really interesting listening to the different perspectives of what Tom had to say and Jacqueline's words. I really found interesting to look at it, the world through her eyes, and what Morris was saying, and then how Jennifer was wrapping it up. And perspective is so important in how we all evaluate the world. And I was thinking how I view Toronto and how Jennifer views Toronto is quite different. She sees Toronto, and how the rest of the country sees Toronto is very different. But the way that I see the world is different as a result of the things that I've been exposed to in life. This is where we are right now. I think you probably recognize there's the Ottawa River and the St. Lawrence at the bottom, and you can actually see the Rideau Canal coming down. This is a picture I took flying overhead here, but if you back away a little further, you can see the whole country. And this perspective is brought by human intuition and human ingenuity trying to figure out a way to understand our world better. And this is an image taken by RadarSat. It's our entire country in one image, in not some sort of bizarre representation, but an actual image of it. Imagine what La Vérendrye would have thought of that, or David Thompson, or Simon Fraser, or someone. And if you back a little further away, if you push yourself to a level of technology that is unprecedented, you can see the whole world in one glance, as the Apollo astronauts did, who took this picture here on their way back from the moon. To be able to see our entire planet, and suddenly you get a whole different perspective. It's not just the concerns local. The local concerns are valid, but if you truly want to address the issues that everyone's been talking about here today, you have to see the whole world, especially with the level of connectivity we have. And so trying to understand that perspective is really fundamentally important, and having the technology to let us see it is really important as well, especially when you compare it to the scale of other things. We think the world is big, but boy, the sun is something else. The sun is this vast thermonuclear, constantly exploding furnace of a thing. And it looks kind of nice in the sky, and we like to be a little closer to it right now. But if you actually look at us in scale, that's how big the Earth is next to the sun. It's this little pipsqueak nothing. The sun wouldn't even know if we were there. But of course, this is really misleading. How far from the sun are we? And people don't understand how far from the sun we are. So I did my best here to try and show you. If you look at this, I made Earth as small as I could possibly make it and still have it show up on a PowerPoint slide. The Earth is 1 pixel. So I don't know if you can even see it over there, so I drew an arrow. Earth is over there. That is Earth. So if you make Earth 1 pixel, then how big is the sun? The sun is that big. So, okay, that's how far away the Earth is. No, that's not right. If you make the Earth 1 pixel and then you draw the sun to scale, we are actually 12 screens over to the right. That's how far away from the sun we are. And we're 1 pixel. Think of how we generate electricity on Earth with that perspective. Think what your little solar panel is trying to do. That sun is exploding all this power in 360 degrees all the way around a ball and sending it everywhere. And we're sitting 12 screens to the right with our 1 pixel holding up our solar array going, we're using solar power. And think of how we use fossil fuel. I mean, we waited until that solar energy went that huge distance and it grew trees and plants, and they fell down, and some animals ate them, and they all fell down, and they rotted in a river, and then they went downstream and they collected for millions and millions of years until finally they rotted into this horrible black muck that then we discovered, and we pump it all up, and then we refine it and burn it, and we stick it into our cars, and we think we're using energy efficiently. It's crazy. We're this little tiny 1 pixel speck. But if this will go forwards, but it's our world, and we don't need to feel inadequate. It's really important to us. And the real question is, what is important to us? And for me to try and prioritize what I want to do in life, I think about that. What are my actual fundamental priorities? And I think they sort of in line with what the other four speakers have all said. And for number one, especially what Tom was saying, is survival. Number one is survival. We want to survive as a species. Number two, though, is the subtle one that flows into everything else everybody else was saying, and that is to raise the standard of living for as many people as possible and make it sustainable. How can we do that? We have been on this huge crushing wave of raising the standard of living for as many people as possible, and this huge accelerated technology-driven rush, but we haven't given much thought to making it sustainable. And how can we match those two things together? How can we make that work? And third, make Canada thrive, with our own little parochial view of that part of the blue ball. But to me, those are the objectives. And fortunately, we are blessed with something that no other species on this earth has, and that is a relentless, restless intellect that allows us to do things like this.
12, 11, 10, 9, 8, 7, 6, 5, start, 2, 1, boost to ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
And the beauty of being able to do something like that is it then allows us to see something like this, where you can glance out the window and see the Great Lakes for what they really are. They are not some massive shoreline that you stand there and go, wow, look at the size of Lake Superior. They're not some ancient, inexhaustible resource. They're not some God-given right of anybody. They are just the drying up puddles from the last ice age. That's all they are. You can see where Georgian Bay used to flow across Lake Simcoe and down. It used to completely bypass the way having to go through the St. Clair and Niagara Falls. They are just a thing that's transient here on the surface of the earth. And boy, it's hard to see that if you don't get yourself the right perspective. Or the gorgeousness of the world, the ancient, dried up nature of some place like the Outback, or the entire planet. Seeing the whole planet is really important if we want to make good decisions about the whole planet. And our relationship with the sun, to be able to not just see the northern lights and look up at them, but to go into them and fly through the northern and southern lights and see how we truly react with all that electromagnetic. This is what drove Canada into the space age, trying to understand the ionosphere and the upper atmosphere. And we were the third nation on Earth in space. In fact, with this humble little satellite in the late 50s and early 60s, it launched in the early 60s, a little over 50 years ago, and it was designed by a really smart Canadian guy named John Chapman and his team. It worked up there for a long time, and it had this cool little sort of extendable robot antenna idea they came up with. They made a bunch of money from it, formed a company that then got the contract to build Canadarm, the absolute world definitive robot in space, driving from a fundamental curiosity about the perspective of seeing the whole world to going through human relentless innovation to come up with this, which flew almost 100 times and released the Hubble telescope and helped build Mir and the International Space Station and allowed us to fly our first Canadians off the planet with the first group of astronauts, and then invited us to be able to be part of the world's space station, of the International Space Station, and our huge robot arm, Canadarm2, which was working this week. In fact, two of the guys had to go outside and do a lube job in the end because the wires were getting a little bit dry down in the end. But this allowed us then to hire another group of astronauts in my class, and then the Canadian Space Agency's two astronauts right now, Jeremy and David, that are training. But it doesn't stop there. It's not just, wow, how does the atmosphere work? How can we figure this out? Let's get ourselves up there, look at it. Wow, that technology has other applications. We can do other things. We can build robots, but it doesn't stop. When you challenge people and enable people, that intellect comes right around full circle, so that there are robots in hospitals like this one in Foothills Hospital in Calgary that does brain surgery. The surgeon sits in another room like an astronaut and operates his remote controls while the robot can be inside an MRI for three-dimensional visualization so that they can remove brain tumors. And there's one being built at Sick Kids in Toronto as well to be able to do microsurgery, actually sew up vascular surgery on newborns. That same technology is being put all around full circle to other applications. But it doesn't even stop there. It's not just scientifically important and financially important and technically important and medically for us. That same drive becomes culturally important to us to the level that we put it on our most common bill. That celebration of what we can do technically becomes something that we value enough to go buy a coffee and a donut at Tim Hortons with it. But we're talking big ideas today. What's on the horizon with all that? Where do we go next? What do we challenge ourselves with? What are the problems that we're being faced with right now? And how does this fit into the overall matrix of the problems everybody else was speaking about? And one of the things is the International Space Station. I think it's a kind of a no-brainer at this point. We have been working as the 15 leading nations of the world to build that thing for the last 25 years. It is the most complex thing, biggest thing we've ever built in space. We're running 200 experiments on it, and it is kind of the manifestation of human space flight from when Yuri Gagarin launched back in '61 right through to the 6 people, Samantha and Terry and Yelena and the crew that's up there right now, the people from all around the world operating the space station. And just day before yesterday, Russia said we're going to sign on for at least another 4 years of supporting it right through to 2024. The United States has already signed up to that. We've only signed up to 2020 in Canada. We built that thing. Canadarm2 put that thing together. That was our technology, built that thing. We've had several Canadian astronauts on board, and we need to sign up at least to 2024 and be part of that project through the rest of its life. But the real big obstacle to spaceflight, and it always has been, is launch. It is the bottleneck. It is the limiter. Trying to break free from the force of gravity, trying to force ourselves up is the real problem. And it's really intriguing to me who's working on this problem. These 3 guys, some of the most brilliant and proven successful entrepreneurs that exist on Earth right now, are all building rocket ships. At the top is Richard Branson, who's trying to do it by using an airplane to haul it up to 50,000 feet and then release his rocket, and that so that you've already slipped a lot of the Surly bonds so it has a chance to get up high and try and get a cheap way to get to orbit. And Jeff Bezos, who founded Amazon, he's actually trying to redesign the rocket itself. He's trying to get into, not just use the same one that Yuri Gagarin used or Neil Armstrong used, but try and change the basic rocket design. And Elon Musk, who started PayPal and runs Tesla, he started his own rocket company, and he's maybe got the most interesting idea of the 3, and that is, instead of that rocket, after it spat its satellite off at the end, trying to have the rocket come back and land again. It spits its satellite off, and then it goes, whoop, does a little loopy thing, comes back, flies down, and lands back on the land, so you can just fill it up with gas and use it again like an airplane, like an airliner. If any of these 3 guys succeed, it will drop the cost of launch by an order of magnitude, maybe 2. And but of course, nobody wants Elon to land his rocket for the first time in their backyard, so he had to build this big barge. He's got this gigantic barge, and he puts it way out at sea, and he's trying to make it rock, and he's tried it once so far, and this is how it went. So not quite there yet, but look how far, that was his first try. That's pretty good. He got all the way over to the barge, and pity the cameraman, right? He got all the way over to the barge, and they found he just didn't have quite enough hydraulic fluid up on the steering paddles up at the top. He's got 8 more times this year to try and do that technology, and he's funding it through other programs that are giving access to space. But when he solves that problem, the cost of access to space is radically going to drop, and that's going to change that's going to change everything. We just haven't even figured out yet what that is going to mean for what and who is going to fly in space. And I think the immediate application will be the ability to put little cheap satellites up. They don't have to be every one a holy grail of a Hubble telescope or a gamma ray observatory, but we can put a constellation up. Maybe we can find a good way to clean up low Earth orbit because you can get things up there much cheaper. There are Those guys right now are saying, if we can make launch cheap, then we can put little transmitter receivers up there, hundreds of them, that are basically throwaway, that will bring internet to the world. And they're not all the way out in geostationary orbit where that ring is. They're not all the way out at 22,000 miles. They're just a couple hundred miles up. So the speed of communication goes fast enough that you can bring internet to the world. And only 40% of the world has internet. There's an untapped market of 60% of the world that is available to try and communicate with each other. And it's the hard 60% too. We've used the infrastructure that exists in order to feed the 40%. So that's why those guys are pursuing it in the short term. They recognize that having the world be able to communicate with each other is a vast untapped market. And it all is hinging through cheap launch. So what opportunities exist for Canada here? We are world class in satellite communications. We led the world for decades. We have companies in Canada that are going to allow those satellites to communicate with each other. We have to use different spectra. Maybe we're going to use optical communication between the satellites. And the security of the communications between them is really important. There's a tremendous market about to erupt as soon as those rockets start working, and Canada's poised to do it right, so long as we get the investment into those companies so that they can lead the world and lead the pack and help Canada thrive. We also need to use that environment to understand the planet better. And Tom talked about the fact that we need to sort of synergistically change how we think about the climate of the world, but we still have to measure it. We have to understand it. We have to see it from the high ground and look at changes. And this is a Canadian satellite we put up in the late 90s called Moppet that looks at pollution and measures carbon monoxide around the world. But being able to map the world that way and understand it is important. And so we need to have those things poised through the Canadian Space Agency and Canadian universities. If it's cheap enough, a university can put something they put together in 1 year up into space. It's going to change how those structures work, and we need to be poised for that as well. And then NASA is talking long term. They've got cheap access to low Earth orbit going on. They want to use all the things we're testing on the space station to eventually get to Mars. Mars is still a long ways away. We're decades, maybe a century from going to Mars. There's all sorts of stuff that, it's really popular in the media right now, but Mars is a lot further away than most people think. And so on the way to Mars, you can stop at Lagrange points where the gravity between us and something balances. You can stay there sort of for free. Or go to near-Earth asteroids, go to the moon. And in NASA's plan that just came out within the last little while, they're planning to set up bases on the moon in order to test and prove where you can still come home if you get it all wrong before eventually, sometime in the future, we head towards Mars. And there's tremendous opportunity for Canada there too. Just as we have, throughout the entire space age, used our intellect to take advantage of it for our own economy and to challenge our own people, it's going to happen here as well. NASA launched this vehicle in December, and it can go to the moon. It's called Orion. But it needs all sorts of stuff. It needs a closed-loop environmental system. What Jennifer was talking about, how do we make a water recycling system and an air purification system that'll work in a really small volume? How can you drive yourself, challenge yourself to come up with a new technology that will then apply all around the world? And Canada could lead the world in that. We just have to decide and commit and decide that's what our part of this thing is going to be. And navigation and radiation protection and communications. And when you land on the surface of the moon, the same problem that Tom was talking about that plagues us all, energy production, in order to drive that huge first wave of feeding and the 7 billion of us now, that even though maybe the Earth has never fed as many people as it feeds today, it's unsustainable the way we've built it. We need a different energy source, and we can't just wait until we burn all the fossil fuels. We need to be driving it and thinking about it and challenging our people, and the way we're going to push our people is to give them things that are right on the edge of very possible. It brings out the best in people. You have to challenge them. And there's some guys out in Vancouver. This thing just looks ridiculously Iron Man-ish to me, but they're General Fusion, and they think they're really close to having useful fusion energy. I don't know for sure. There's some people say, but there's a lot of investors are putting a lot of money into them, saying this is really something that's possible. And so that type of technology, you need to inspire the people, you need to enable the people, and then allow them to reap the benefits. And for me, maybe the most important idea out of everything we talked about, the 5 big ideas, is how do we inspire our young Canadians to do things that they might have never otherwise done. I think the biggest wasted resource in Canada is any single one of us who has not tapped our entire potential. If we just had every single person in the country feel both enabled and educated and respected enough that their contributions, the things that they can come up with their mind, are going to give them opportunities and fit into the fabric of Canada, that is the most vital product of our whole educational system. And to think what this little girl, somebody sent me that picture of her, but to think the opportunities that we have built that exist for her, that did not exist when we were her age. And therefore, the things that she sees happening, but also the choices she's going to make with her life as a result of what we have all built and the continuing restless intellect that drives this entire country. Thanks.